What is variance of y? How do you find the variance of x? Expectation of x minus expectation x, the whole square. So what will be the expectation of yt? Expectation of yt minus expectation yt, the whole square. So what is yt? Yt is here. We have expectation yt here. Because all these are 0, right? So expectation yt is alpha upon 1 minus 5. So therefore what will be variance of yt? It will be expectation of yt minus expectation yt whole square. Yt minus expectation yt whole square. Okay? Right? Which is what? What will that be equal to? So this minus this whole square is expectation of et plus phi et minus 1. So, right friends? Whole square. Okay? Right? Now in general, what we are doing is, we are looking at the variance of this whole sum. And we are looking at the variance of this whole sum. Right? What is variance of x plus y? Variance of x plus variance of y plus 2 covariance x. So, if I want to take the variance of this sum, it will be the variance of each individual term. You have to add the variance of each individual term and then add all the covariances. Fortunately, we have assumed that all the ETs are independent across time. So the covariances will be 0. So what you have is, you really get the sum of the variances of each individual term. So it will be the variance of this, plus the variance of this, plus the variance of this, etc. So what is variance of ET? Sigma square. What is the variance of phi ET minus 1? Phi square sigma square. Because variance of alpha x is alpha square variance of x. So this will be phi square sigma square. What is the variance of phi square ET minus 2? Phi square square. Right? So I just write here phi square square sigma square. What is the variance of phi cube et minus 1, et minus 3? I write this as phi cube square and so on. Right? Sure folks? This can be written as, I can take sigma square out common. I'll get 1 here, phi square here. Next term will be phi square square. The next term I can write as phi square cube. Phi cube square is the same thing as phi square cube. Right. So I can write this as phi square cube plus phi square raised to 4 and so on. Which is the geometric series in phi square? So what will this converge to? 1 upon 1 minus phi square. Right? So this is equal to sigma square E 1 minus phi square. Right? Okay? So friends, if your process yt was 2 plus 0.5 yt minus 2 plus et, and I told you that et was a standard normal variable, what would be the variance of yt? If I told you that et was a standard normal variable, standard, I'm stressing on the term standard, so some lighting lights up. What would be the variance of yt? Sigma square E upon 1 minus phi square. What is sigma square E for a standard normal? 1. Right? What will be 1 upon 1 minus phi square? 1 upon 1 minus 0.5 square. So 1 upon 1 minus 0.25. 1 upon 0.75. Right? What is 1 upon 0.75? 4 by 3. Because 0.75 is 3 by 4. So 4 by 3 will be the variance of yt. So the mean of yt will be 4. The variance of yt will be 4 by 3. Right? Variance of yt will be 4 upon 3. Is this clear? Sure? Everybody gets this? Okay. Now, let's find out what will be the covariance of yt minus 1. Okay? What will be the covariance of yt minus 1? Very important. What is the covariance of yt minus 1? Okay? Right. So what do you think, friends, with the covariance? How do you calculate the covariance of yt minus 1? So what will be yt minus 1? First, if this is yt, what will be yt minus 1? Yeah?
If phi is equal to 1, will the variance also be undefined?
Naturally. So phi is equal to 1, variance will not be defined. And not because it's phi square is equal to 1. Because that sum will not exist, no? There will be 1 plus 1 plus 1 plus 1 plus 1 plus 2, variance will be an infinite quantity. So for a random walk, even the second condition for stationarity will fail. You see the difference between a trend stationary and random walk in this case is, for a trend stationary process, expectation yt exists. Expectation yt is alpha plus beta. So if you give different values for t, you know what is expectation yt. It's a function of t. Right? The second condition, variance of yt is constant, the covariance of yt doesn't depend upon time. Whereas for a non-stationary process of the DS class, that's for a random walk, the mean variance don't simply exist. And we'll also see the covariance will not exist. Right? Mean variances simply don't exist. Right? So it's a very different type of non-stationary. If you have a different stationary process, it's quite different from a trend stationary process. Stationary process, mean is defined, the variance and covariance are all fine. The mean is not constant but is defined, well defined. Whereas for a non-stationary process of DS class, for a random walk, a simple random walk, the mean is not even defined. The variance is not even defined. Right? So if things are not defined, how do you, if I say yt is a random walk, so take y bar t. So you can't take, for example, if I tell you that yt is a random walk and this is the data that you have, y1, y2, y3, y4, test whether this data come from population with mean 4. That's a meaningless question in this context because the population mean, constant population mean doesn't really exist. Which means that you cannot do those TF, chi-square, etc. Right? As long as you understand this intuitively, do you understand this intuitively? The problem is, why can't you use a standard test of hypothesis with non-stationary data? Is everybody getting this? Right? Yeah, the logic is, as we said, if you have a non-stationary time series, if you have a random walk, then the variance of yt is not defined, expectation yt is not defined, right? So suppose I tell you that this is a data generated from a random walk, y1, y2, y3, y4 are some observations. Suppose there are share prices from a random walk. I ask you to find out whether these prices could have come from a probability distribution with mean 4. It's not the correct question to ask because the mean of a random walk is not defined properly. So you can't do y bar, so I take a sample mean y bar, subtract from it 4, divide by the standard deviation. You do not have to calculate the standard becomes a t. It can't. That logic doesn't work. That is why if you have a random walk, you cannot use the standard TF, chi-square and Z statistic. This is a very important point. Please remember that. Right? Okay, otherwise, if I have to prove this point to you in your third and the fourth semesters, I have to do a lot of complicated maths and show that there is a weird distribution and weird formulae. But intuitively, as long as this sinks in, it's a very, very important point. Okay, so Please remember. So if you're doing things on financial markets, for example, right? If you suppose, see, this is one of the problems with finance analysts do. They have data on, say, stock prices, and they will say, let me find out the volatility of the stock price by calculating its variance. The data are a random walk. So you can, if you have 100 observations, you'll obviously get some y bar. By definition, Excel will calculate that. You'll get some y1 minus y bar square, y2 minus y bar square. If you add all those terms and divide by n, you'll get some quantity, but that quantity is not the variance of y, because the variance of y is formally undefined. Excel will calculate some variance. So you cannot say that the volatility of this stock is more than this stock, etc., etc. And then you can do, for example, an F test to compare variances, which is more volatile, when they have come from a population, the same population. You can't do that with financial data, right? Or asset prices. If you look at prices of metals, for example, if you look at price of gold, silver, wheat, food grains, right? In markets where there are where there are no restrictions, where there are forward markets, where markets are open, wherever there is possibility of arbitrage, when people are buying today to sell tomorrow for a profit, you will generally not be able to apply the standard T, F, chi-square, Z test. Right? This is something very important. Okay, so please remember that. Okay, so suppose I have this. So what will be yt minus 1? Alpha upon 1 minus 5 will stay at this. What will et become?
et minus 1
Plus 5 it will go like this. So 5 raised to j et minus j nahi hoga, 5 raised to j et minus j minus 1, because here 5 square is t minus 3, right? Right, it should actually be j plus 1, no? 2 by 3, because this index has to be 1 higher than this. This has to be 1 higher than this, right? So it should be et minus j plus 1 and so on. So you'll always beware of doing regressions on time series data, because of the reason that I just told you, right? Okay. So here it is. Now, what will be the covariance of yt minus 1? Let me call this term gamma 1. Gamma 1 is the covariance of yt and yt minus 1. Gamma 2 will be the covariance of yt minus so on and so forth.
So there we need to minus j minus 1. Why into j minus 1?
हा है ना, हा actually एक जास्त आहे ना त्यापेक्षा.
That is why we need j minus 1.
नाही बस आता
Why into j minus 1?
हा j असेल तर j प्लस होणार ना. हा 2 आहे तर हा 3 आहे. हा 1 आहे तर हा 2 आहे.
Right.
मग हा जर j असेल तर हा काय असणार? j प्लस 1 ना. मी ब्रॅकेट मध्ये टाकलं बरोबर, कारण तो ब्रॅकेट ओपन झाली तर j minus 1. Yeah, so if you open the bracket, it will be j minus 1. So
minus j minus 1, right?
yeah, minus j minus 1 ऐसा हो, right? So if you want to write it like this, but that's right.
कमीच होणार सर.
हाँ?
j minus 1 केल्यानंतर एक कमी इकडे होणार खाली t minus
अरे हा काय आहे?
जास्त आहे.
एक जास्त आहे ना, माझ्यापेक्षा एक जास्त पाहिजे ना ते t मायनस जे काय आहे ते. हा जर 2 असेल तर 3 पाहिजे ना, मग हा जर 2 असेल तर हा काय होणार? 3 होणार, j प्लस 1 आणि ते ब्रॅकेट काढलीस तर j minus 1 होणार, right? Okay. Now, what will be gamma 1? What will be expectation? What is expectation xy? What is covariance xy? Confused?
No.
What is covariance xy? What is the formula for covariance xy? Expectation of x minus expectation x into y minus expectation y. So what would be covariance yt minus 1? Expectation of yt minus expectation yt, right, into yt minus 1. Yeah, expectation yt minus 1. Okay. Now what is this quantity? If this is yt, this is expectation y. So what is this full quantity? This whole thing will be is equal to